Hey, how's it going? Is it recording? I can't tell if it's recording. Yeah, okay. Q1, compute alternating sum. This is the weekly contest 470. You're given an integer array nums. The alternating sum of nums is the value obtained by adding elements at even indices and subtracting elements at odd indices. That is, boom, 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 return an integer denoting the alternating sum of nums. Okay. S equals 0 for I in range 0 to length s, comma 2. S plus equals nums of I. Can't easily use string interpolation for this because sum will malfunction if you handed an empty list. So return S. Type int has no length. I always do that. Range. What is S? What am I doing? Okay, I take it back. I don't always do that. That was just straight up weird. Okay, 16, 100. Oh dear. Oh my goodness. That was a stupid mistake. -4, 100. Submit. Alright, okay. Weekly contest. Longest subsequence with a non-zero bitwise XOR. You're given an integer array nums. Return the length of the longest subsequence in nums whose bitwise XOR is non-zero. If no such subsequence exists, return 0. A subsequence is a non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Which means... yeah, if you had like one bit that you needed to recover, or you could have all of the bits flipping. Yeah, I'm just trying to think here. One longest subsequence, 2 of 3. The bitwise XOR is computed as 2 XOR 3 equals 1, 10 to the 5th length, right? What if we calculated each of the bits separately, and then we just knew that we needed at least one odd? Is that really necessary, though? It's like there would be... You just need one value at one point that isn't the same as what you currently have, right? So at most, you would need 2 different values that you would have to store. Just trying to think here. All right. Okay, nums. First off, if sum of nums equals 0, then return 0. Return the length of the longest subsequence. Yeah, so otherwise the min length is going to be 1. Excuse me. Yes, the min length. That's what I meant to say. I think that we should aggregate on... I think that we should figure out the aggregate and then take out at most 1. I can't envision a scenario in which that wouldn't work. So XOR equals You know what? I'll just do it like this. For I in nums x XOR I, like that. All right, now if x doesn't equal 0, then return length of nums. Otherwise, we have to remove one element. Is there any situation in which that wouldn't work? No, because we know that there's at least one with one bit somewhere. And if they're all flipped, then flipping one of them is going to recover one of the bits. It doesn't matter what happens to the other bits. So otherwise, return length of nums -1. I thought we were going to have to do some weird stuff. This turned out to be pretty easy. Assuming I'm not wrong. 2, 3, yeah. Boom. All right, submitted. 1,000 passed. Sweet. Okay. Remove k-balanced substrings. You're given a string s consisting of opening and closing parentheses and an integer k. A string is k-balanced if it is exactly k consecutive parentheses followed by k consecutive closing parentheses. Okay, for example, you must repeatedly remove all non-overlapping k-balanced substrings from S and then join the remaining parts. Continue this process until no k-balanced substring exists. Return the final string after all possible removals. What? Okay. Okay, so they can't be overlapping. But they would never be overlapping. That doesn't even make sense for them to be overlapping. Right? Like, is it just me, or is this, like, really easy? Like, something seems wrong here. Maybe there's some complication that I'm missing. They have to be non-overlapping. Okay. While SS in S, S equals S dot replace SS with nothing, return S. Okay. Return the final string after all possible removals. Okay, so empty, and then the output is bum 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 bum, and then in this one the output is boom boom boom. All right. All right, 10, 12 of 10, 12 test cases passed. Sweet. Okay. Count no zero pairs that sum to n. A no zero integer is a positive integer that does not contain the digit 0. Oh, okay. Given an integer n, count the number of pairs A of B. A of B are no zero integers. A plus B equals n. Return an integer denoting the number of such pairs. Okay. Let's see here. I think we're going to have to use either dynamic programming or recursion to do this. I think we can figure it out on a digit by digit basis. At least that's what I think. Okay. So let's go LRU cache none. Yeah. So target, just target, that's it. Just target. Yeah. So if target is less than or equal to yeah, 0, then return 1. There's one way to do it in that case. This is not going to work, is it? Yeah, maybe it will. Maybe it will. Okay, let's see. So n is, okay, it's at least 2. All right. So total ways equals 0, I in range 1 to 10. Let's pre-compute these. For j in range 1 to 10, so it's going to be ways that carry a 1, and then there's going to be ways that don't carry a 1. So we're gonna pre-compute this here. Okay. So sums equals boom. 20, right? And then sums of I plus j, which the most it could be is 18. Plus equals 1. Print sums. 0, 0, 1, 1. Okay, yeah, that looks good. All right. Can I access it like that from a static context, or do I have to? Output std out. Yes, that works. Okay. So we are going to come down here. All right. Total ways equals 0. So if target is greater than or equal to, okay, so first off, we want a desired digit, right? A desired digit is going to be target mod 10, and it's just easier to type one digit. Target mod 10. So right off the bat, yeah, we are not allowed to do a 0, 0. So if there is a 0, then we better hope that there is another 1 in the next place, or else we are kind of hosed. So solution dot sums of d, and then if target is greater than or equal to 10, then yeah. So this times R of target minus D, right? Target minus D. Ah. But we're going to the next digit, so what have I done? Wait, do we need to do that? We don't need to subtract D. That'll get rid of the D for us. Ooh, that was almost stupid. All right. Yeah. Total ways plus equals solution sums if target is greater than or equal to 10 and D does not equal 9, because obviously, you know what, let's just put that in there, but whatever. Yeah, there is no 19. All right, then target divided by 10 minus 1. And solutions plus 10, right? Return total ways. Classic recursion problem. So return R of n. Now it's going to be sad time when it doesn't work. So 2, 8. I wish there were a larger example, but whatever. All right, let's try submitting it, and wrong answer. Use test case. Okay. So it expected 9, and we gave 7, right? Okay. Should be 9 given 12. Let's try to figure out what's going on here. So 9. Can we figure it out? For the last digit, nothing adds to 1. If D equals, if D is greater than 1, then that. Otherwise, we start off with a 0. There's no reason to do the recursion case for no reason. If target is greater than or equal to 10, and D doesn't equal 9, yes. Okay, so we come in here and we have a 2, right? That should give us 1 and 1. And then that will give us a 1 in the next digit, which gives us a 0, and there's nothing that we can do with that. But we come down here and we say total ways plus equals D plus 10, in other words, 12. So what is that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is going on? Did I calculate my sums incorrectly? For I in range, for j in range, t equals I plus j, if t equals 12, print I comma j. Okay. They're telling us that there's 9 ways. 1, 2, 3, 4, 5, 6, 7. Does it expand? 1, 2, 3, 4, 5, 6, 7. Did I misread the problem or something? That looks right to me. 3, 4, 5, 6, 7, 8, 9. 9, 8, 7, 6, 5, 4, 3. Okay, a no zero integer is a positive integer that does not contain the digit 0. Give it an integer and count the number of pairs a comma b, where a and b are no zero integers, and a plus b equals n. Return an integer denoting the number of such pairs. What am I missing? No, you can't have 10. Wait a minute. Yes, these are the one-digit ones. That is correct. But you could also add 1 plus 11 and 11 plus 1, right? Okay. And those are our extra 2. So we have to figure out all right. How does that affect this? Well, yeah, but we're supposed to allow it in the next. Oh! I'm not allowing zeros. Okay. Okay. We allow a 0 if and only if the... Okay, I got it. So at any point in time, we can say that the other digit has terminated. If target does not contain a 0 in it, okay, so here's what we got to do. Both integers running, right? Well, no, not both integers running. Okay, left done, right done. But why? What does that accomplish? Left done, right done, why? It means that we can't do any more digits. So I was initially imagining both of the integers being the same length, which I agree. That is a mistake. I should not have assumed that. It almost seems like we need to start from the left instead of the right. Because we can only count things if we have started using one of the digits, right? Okay, we can use the left, we can use the right, it doesn't matter which one we're using, as long as we, okay, I gotta start over. Okay. Left started, right started. This is getting ridiculous. Okay. Digit. I mean, we can just assume that anything before the left or right is started. And then continue from that point, right? And that's as long as there isn't a 0 in those positions. Wondering if I'm giving up on my original approach too quickly. There's just one extra case, right? If target is less than 0. Let's try it from the other direction. We have quite a bit of time left in the competition. Okay. So D equals 1, while D is lesser than N, not M. D times equals 10, right? Assert assert N divided by D is lesser than 10 and greater than 0, right? Well, D is lesser than N. So D is going to be greater than N, and then we have to undo the last one. Does that work for 1? Okay. So left started, right started, and digit. So target. Okay, leading digit. Leading digit is target integer divide digit, right? And then remaining equals target, well, digit times lead. Assert target equals lead plus remainder, and is 0 allowed? No. 0 is less. Well, yes, it is, because there could be a 0 in the middle. Lesser than or equal to lead is less than 10. Equals digit times lead? No. equals target minus digit times lead. We want to remove the front digit. And then the number of ways that we can get that, we can either carry a 1 from the next digit. Yeah. So one of the two digits has to be started. All right. If, okay, we'll say ways equals 0. If left started, then we have to use left, right? We don't have a choice. If left started and right started, there's 4 different combinations. Then we have to use them. There is simply no choice. Expected carry. I guess we don't have a choice. Yeah. Left started and right started. Now if it's 10, I think you always have a choice to carry, unless it's literally a 0. Okay. If left has started and right has started and we're at 0, if carry equals false and lead equals 0, then return 0. Cannot accommodate. Okay. Yeah, more is needed here. If left is started and right is not started, we can either keep using left or add right. If target equals 0 and digit equals 0, okay, if left started and right started, then return 1, I guess, because we're done. Otherwise, if we haven't started one of them, then return 0. So if left started and not right started, then we can either keep using left or add right. Exactly. So I'm just trying to think here. I really think that I'm making this too complicated. Getting a little bit frustrated. The rest of the match was so easy. There's too much crap here. This is ridiculous. I think I need to do something like I did before. This isn't working. There's just too many. I'm going to code something wrong. Let me just put it that way. What if we assume that left and right have been started? left and right started. Right? If target is less than 0, assert false. That's stupid. Assert target is greater than or equal to 0. If target equals 0, then return 1. Right? Yeah. Okay. Let's not do that. If target is less than 0, then return 0. That's fine. Okay. Now, left and right running is what we should call it, but they are allowed to end. But if they end, then we're done with that run. So, okay. If 0 in str target, if 0 not in str target, ways equals 0, then we have the option of putting it on the left one or putting it on the right one. Ways plus equals 2. That literally would have fixed our problem last time. Yeah. So this is the termination case. So we're stopping either left or right, and that's what the 2 is, left and right. Okay. Now we do basically what we did before. D equals target mod 10. Okay. So now, if D is greater than 1, I wish I had my original code back, then ways plus equals, not sums, solution dot sums of D times R of target integer divide 10. Okay. Now, if target is greater than or equal to 10, then ways plus or equals to D plus 10, target divide 10, minus 1. And that's our carry case. And just return ways, I guess. Oh. Prematurely upset. Oh, come on. Okay. Output 3. That one was my fault. That one was my fault. Okay, so sum of R of n minus A minus B for A in range 1 to 10, for B in range 1 to 10. That was my fault. Okay, 2, 1. Oh dear. Crap. in the hell did I just do here? Okay, W equals 0. For A in range 1 to 10. That's what I get for trying to do a quick fix. Okay. If A plus B is lesser than or equal to n, and A plus B mod 10 equals n divided by, or mod 10, then W plus equals R of integer divide 10. Return W. I have no idea what that last thing I did was. So 2, 1, 3, 2, 11. Oh dear. Yeah. We have to allow the termination case, but we just don't recurse on it, right? I think so. A plus B mod 10 equals n. Okay, 1, 2, 8, 9. Holy crap. Did I get rid of all the print statements? Line 25. I don't even know what this means. That was our digit stuff that we're not even using anymore. All right. So 10, that should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be 9, right? And this should be 9. Please work. I'm ready to go to bed. All right, accepted. So got all of them. And everybody's happy. All right, see ya.